Let me begin by introducing myself in the first person singular. That is what I use all the time. My name is Narendra Kumar, Emeritus Professor at the Raman Research Institute now, and its former Director. I am about 76 now. It is an age where the memory begins to show signs of fade-outs and also tends to lapse at times. I have therefore made some short notes to help me navigate through this interview. I hope you don't mind, but if you do, my apologies are due. Very briefly, I am basically an electrical engineer turned theoretical physicist by choice. I have been deeply fascinated, though, by what I call the unreasonable effectiveness of mathematics in physical sciences or natural sciences in general. Because my early childhood was spent when I was in Ranchi. I was too small. I have very vague memories of that now, except that I was interested in science even at that time. I had a compass, I had magnets all the time with me, under the pillow also. Not one or two magnets, but up to 20 magnets, bar magnets. They were my constant companion because I could never get over the idea that there is something called magnetism, even though I had no idea about the physics of it, but I loved it. Faraday, Maxwell, and Schrödinger have always been my abiding heroes. I have been ever inspired by the life and science of Sir C.V. Raman, as recollected very beautifully by my good friend G. Venkataraman in his book called Journey into Light, Life and Science of C.V. Raman, 1994. My father, his name was Labmal Julka, too was an electrical engineer, graduating from the Banaras Hindu University. He was born in Sialkot, which is now in Pakistan. My mother, Taravati, never went to school, but she could read, write and speak in 4 languages: Hindi, Urdu, Punjabi, Gurmukhi. She was born in Jammu, that's up north. We were 3 sisters, all graduates, and 2 brothers. I was youngest in the family, born in Bilaspur, Madhya Pradesh, I think, now, in 1940. My wife, Ann Kumar, born in Bangalore, I mentioned to you, is an economist. We have 2 daughters, both now in the US. The elder, Revati, is a physical chemist, and the younger, Rohini, is a mathematician. The very first thing I will tell you is, I was taught at home by my father till I was 7 years old, which is quite old age actually in some sense, and was then admitted to Dayananda High School in class 8 in Patna, that is in Bihar. I still recollect vividly the motto of my school. At the very entrance, it was inscribed, Tamaso ma Jyotirgamaya, Krimanto Vishwam Aryam. By the time I finished my BTech and MTech, it was clear to me that my heart lay in physics. It was not in technology. So I loved engineering and all, but technology, but my heart was in physics. And that too, theoretical physics. and being, of course, an electrical engineer, by training, a transition to theoretical physics seemed virtually impossible. I'll give you a small example of this. The physics department of the University of Pune, was just about next door, maybe a few kilometers. But its doors were totally closed to me as an electrical engineer. They wouldn't have me. They would have me for the engineering, high position, but not in physics. And then, of course, I had a real breakthrough. It was just this. Professor K. Venkatraman, the then director of the National Chemical Laboratory, NCL Pune, not very far from IIT, where I was, would be pleased to have me as scientist B with several advanced increments if I could only look after their NMR 60 machine as an engineer and in later time do whatever I want to do. It was Maxwell, who was basically an electrical engineer who did so much work on electricity mechanism, that published a paper from here and published resonance, actually. It was a phenomenon that he had himself discovered and made a device out of it. Now we don't find it anywhere, actually. Other things are overtaken. And no, I couldn't find any literature on that, but I had read somewhere that did something of this kind. So I tried to reconstruct what he must have done. And I made that device, which was the paper published in Resonance. Electrical engineering was always in my mind. I thought that way as an electrical engineer. I did physics, but my thinking was that of electrical engineering. I will imagine magnets, wires, currents, forces, things like that. That's how my brain worked, actually. But what I did finally was theoretical physics. In British Columbia, I met one of the most wonderful person in my life. Inimitable Professor Amateur Price, the Fellow of the Royal Society, London. And I interacted very strongly with him. But he was a man of principle. He taught me so much, but he wouldn't write his name on my papers. I could thank him, that's what all. That he would allow. Such people don't exist anymore, is my belief. I published several papers, independent papers now, there, the most notable being one on Jahn-Teller effect, a very important effect, and my title was Jahn-Teller effect and superconductivity, published in Physical Review B. I should add that Jahn-Teller effect was very close to the field of Professor Amateur Price, though his major field was spin Hamiltonians, another subject, very important subject in physics, theoretical physics. At the physics department of the Indian Institute of Science, we had a very strongly interacting group of students and research colleagues. And it was just wonderful working with them. And I remember almost all of them by names, even the students. Thus, for instance, we had a very brilliant student by the name Arun Janawar. He's now a fellow of the academy, actually. And at a very early stage, we wrote a very interesting paper, and it was on what's called non-diffusive quantum transport in a dynamically disordered medium. It was published in the reputed journal Physical Review. And I'm very proud of that work with Januar, and it was an interesting solution of a problem which has been evading people for a long time. Namely, what happens if a particle moves quantum mechanically in a solid which is disordered in space. And it turns out that there are surprises there. As I mentioned, this was published in Physical Review Letters, which is a very prestigious journal. Now, something about this student is very important, and I'd like to mention that. See, all my students, whenever I refer to them, I always say, my students, I. I never say, I and my students. My students actually always come first, and he was first among them, actually. I would ask him, why were you so late for the class today? He said, there was no breeze in the tire of my bicycle. Breeze in the tire of bicycle. How interesting. And then I had a very serious student by the name Ari Amitkar. We worked on various superfluids, and I think he made some very important subtle contributions in this particular area of low temperature physics. And then, of course, there was a very bright student by the name Anil Kumar, Bhuri Anil Kumar. He was always a man full of humor, but actually a very serious researcher. Now he's in the University of Texas as a professor. And we worked on problems of quantum diffusion, which has been of abiding interest to me, and phase transition too. And we wrote several papers, interesting papers, in these fields. And then there were other students. In fact, there was a girl student by the name Nandini. And with her, we worked on a problem of a rotating, self-gravitating star. And the question was, will it generate a magnetic field on its own? And the answers were very interesting. Turns out it does. Rotating, self-gravitating neutral star generating a field by a kind of gravitationally induced effect. Gravitation plus rotation in the presence of electrons, of course. And it was published in Physical Review D, a very important journal. Then there were other students. I can actually go on and on, but I think I've given you some idea about it. Then there were senior colleagues like Professor K.P. Sinha, with whom, of course, I interacted. I was a student, his PhD student, and earlier. And we interacted on almost everything and anything that we could think of. A wonderful man to work with, a researcher of the first order. But as I said, it was all between Indian science, but also the Raman Research Institute, where many of our students were common later on also. And we worked on several problems of that kind, of common interest. Main interests have been, during my stay in Institute of Science, on a problem called quantum and classical transport in disordered systems, and some localization, superconductivity, phase transition. I must mention, we also had several experimentalists there, and a very notable example would be Professor Ajay Sood. And we worked on whole lot of problems on liquids and states connected with that. Then there was Professor S.V. Bhatt, with whom we worked on superconductivity, a whole range of problems of experimental interest. So that was about part of what I did. It will always be with me as part of my inalienable memory. As I mentioned, I also interacted strongly with the Raman Research Institute, where I moved to later on, and we had a number of interesting problems to work on, and we did that too, particularly on optics, quantum optics, and problems of light and matter interaction. I must come to perhaps the most important work that I have done in the course of my life, and was also done in collaboration with a colleague of mine, Professor Pierre A. Mello, and a colleague of his by the name Dr. P. Pereira, both at the University of UNAM, Mexico. And it was all about what is called resistance fluctuations in disordered wires. This work was published in Annals of Physics and became almost like a citation classic. And we addressed important problems. It is now known in literature as the DMPK equation, which is derived, where D stands for Dorokhov, M for Mello, and P for Pereira, and K for Kumar. So it's called the DMPK equation, and that's how it's referred to now in the literature. I also had colleagues visiting us at the physics department from other parts of the world, and a most notable visitor has been Professor Jean Heinrichs. I had a long interaction with him in Liège, and we have been collaborators since then and published dozens of papers. Much of our work, partly done in collaboration with him at the Department of Physics, was on again quantum diffusion and disordered systems, and many aspects of this rich field. And I'm very proud of that work that I did with him. So I looked around, what is new now happening in the world? It is at that time I realized, it came to me, that light somehow, the role of light, which is from the time of Raman, plays such an important role, must be explored further now. There was a time when people were using light to cool atoms, so-called cold clouds, down to nanokelvin, 10 to the minus 9 degree Kelvin temperature. So I thought we had the tradition of light, Professor Raman. So why, and we had some colleagues too, directly interested in this. So why not we enhance this capability? So I decided to start off, which became finally, it was called LAMP, Light and Matter Physics, where, as I mentioned to you, we obtained the first time cold cloud in alkali atoms, but at microkelvins, not nanokelvins. That group, of course, has now expanded. It's a big department now. At RRI, the Raman Research Institute, I was fortunate to have in our midst some of the most creative minds. Thus there was Rajaram Nityananda, Professor G. Srinivasan, or called Srini, Professor Joseph Samuel, we called him Sam, and Professor Rajendra Bhandari, and there were some others as well. But it was a very small group. It was expanding. We appointed many people, but then we need more space. So What was earlier the liquid crystal laboratory, we built a story about that. And that became TP, Theoretical Physics, where apart from other physics, general relativity was also a part of that, gravitational wave, and many other things came up along with that. To my mind, RI is the most beautiful, has rather, a most beautiful ambience in which to work and do first-rate science in peace. We are not disturbed here. It's a very quiet place, but activity is in the mind. I heard about it first very generally when I was in British Columbia. Amateur Price was a fellow of the Royal Society. He knew about Raman much more than anyone else does. So Academy was very much there and in his mind, and I learned from him. And the kind of person Raman was, he knew about him much more than certainly I do. So that was the first time. But then I almost forgot all about it. However, there was later, when I came to the Indian Institute of Science, these things came back to me. By the time I returned, or when I returned to the Indian Institute of Science, I told you, to get my PhD degree, and I became assistant professor here at IASc. That was a time when Professor Raman had passed away. To my everlasting sorrow, because I could never meet him. So the Academy came back to mind with full force at that time. The name of Raman, because when he went away from the scene, the Academy came alive somehow. Oh my. Academy expects something from me because they did so much for the Academy, RAD and all. So I have to do something for the Academy, not just do my science. Of course, that I was doing, but something a little more than that. No, it was quite a simple affair, actually. Though to be president of the Academy looks something, something to be very proud of, and I am proud of being that. But actually, the process was quite straightforward, as far as I could see it. I received an invitation from a very distinguished senior colleague of mine, Professor P. Ramarao, to have dinner with him at a restaurant downtown in Bangalore, which I gladly accepted. I never said no to food, I mentioned earlier. After the menu was ordered, he relaxed and said with a smile that he and many of his senior colleagues would like me to be the next president of the Academy. That's what he said. I felt greatly honored, but then I was also dismayed too. I must have some more time to think, which was granted. That night I went back home, went through the relevant parts of the Academy yearbook. As a fellow, I had a copy of the yearbook at home. Next morning, I drove to the Academy House, located northwest corner of the institute, that is RI, and just looked around pensively. What institute is this? I also gazed at the lush green lawn of RI in the front. I had made up my mind. Shortly thereafter, I was elected president of the Academy 1998 to 2000. Some notables about the Indian Academy of Sciences. The stated objective of the Academy is to promote the progress and uphold the cause of science in both pure and applied branches. It has a logo but it has no stated motto. I would strongly suggest that the Academy stay numerically compact and small, but strongly interactive. These interactions too then interact, a strong multiplier effect. The most important function of the Academy is the election of its fellows, the highest decision-making body of the Academy in all matters relating to the election of fellows, FASCs, is the Council. One of the most important regular events, now I come to some of the events which are very heartwarming. Event of the Academy is the annual meeting. In my time, we had 3 of them as usual. The first one was at Kottayam in Kerala, in 1998. The second at Lucknow, 1999. And the third was at Goa, Panjim, in 2000. It is at the annual meeting of the Academy that the newly elected fellows of the Academy are introduced to the audience by the President. So it's a very important and solemn occasion. This is followed by the presidential address, which is of course given by the President, which is me in this case. But my presidential address was always based on, or focused on, the research work in which I was directly and personally involved. That was my motto. I will not talk about anything in which I have not been directly involved, particularly in science. That's the Kottayam I talked about. The title was Waving Through Randomness at Maximum Entropy. It's a combination of some kind of wave theory and statistical mechanics or thermodynamics. It was held, this was in Kottayam. At Lucknow, I spoke about the quantum Zeno effect, which is basically why if you make repeated observations quickly, the change doesn't take place. For instance, if I keep on looking at you at short intervals, you will be exactly as young as you were. You will not age. No change is allowed. If you are observed very, very closely, like very continuously, you can say. So it has importance that way, but actually it's a problem in physics. Professor Sudarshan, a great Indian physicist, had done a lot of pioneering work in this field. At Goa, my address was on cold atoms, a very hot subject. I mentioned to you the cold cloud and at nanokelvin. At annual meetings, we also had, these annual meetings, we also had technical sessions, many of them, several. Discussion of various science-related issues, sometimes social issues, of course, and there were evening lectures. There were cultural programs too, and of course, the food. I mentioned to you earlier, I'm very fond of food. And food there always had a touch of local cuisine. Why was it important? It is very important, mostly because the fellows were often accompanied by their spouses, sometimes even young boys and girls, the children. So these things were important. An academy thinks of everything, because nothing is outside science, as far as academy is concerned. In my time, I enjoyed most our annual meeting at Kottayam. I told you why. It's lakes and several other things. I don't want to go into details of that, but they're well documented, the produce of the land, and other water bodies, and water birds and things like that. I also enjoyed greatly the midterm meeting, which is a non-statutory, in the woods of Orange County, which was in Kurg, where the river Kaveri takes a bend. It's a beautiful place, I must say that. Now I come to my other interests, and they do really interest me. I love to travel, and I have traveled extensively in India and abroad. I enjoy walking, swimming. I used to play badminton in the past. I have been a voracious reader, actually. But my favorites are P.J. Woodhouse, Mark Twain, and, if I may say, Sherlock Holmes of Conan Doyle. I eat heartily, not hardly, almost everything, but I don't drink. I enjoy giving semi-popular science talks to students, always to students here. Sometime back, I had given a semi-popular talk at the Fellows Residency, not very far from here, of the Academy, with the title Why? Actually, why and how? Some examples of that. How does a cat in free fall, a cat falling freely, manage to right itself so as to always land on its 4 feet? All fours. Is this really a case of zero angular momentum turns? To turn, you have to have angular momentum. But to start with, the cat had no angular momentum. So is the case of zero angular momentum? Can you turn around without angular momentum? Answer is yes, you can. And cat is the best example, living example of that. We all know why the sky is blue. We all know, it's a common knowledge now. But why is it dark at night? Why do rivers meander? This is well understood, but interesting. What about the upending top? The top, you turn it, and after some time, upside down. Why? There's no violent angular momentum? Answer is no. And there is something very subtle called the spinning Euler disk. I strongly suggest that young students may do well to play with these whys and hows. In my writing, whatever I'm talking, I always refer to students and some elderly advice to them. This is my advice to them. Don't take toys very triflingly. You can play with them, but try to understand why it is the way it is, why things are the way they are. Actually, the Academy is doing a lot already in terms of lectures, for example, in terms of various programs. I mentioned to you about this Academy residency, where I gave a talk on why. The students also come there. No? So programs which are explicitly aimed at students who are motivated, and so the fellows should also interact with them. It makes a big difference. If a fellow is interacting with the students who also come to Academy, it makes a very big impact because they are role models also. No? It seems somehow the world of science is moving more towards technology. There is no doubt of the fact. But science is becoming more and more specialized and very subtle and difficult to pursue. Technology has applications directly, which are tangible. So it's understandable. But my feeling is, it is one of the few academies, I think, which can and should continue in pure sciences. Pure sciences, including, like physics, chemistry, biology, all that. Engineering science is also included, but that aspect of it, which has to do with science. Engineering per se must not be part of this engineering, only the aspect which has to do with science. So, for example, when you have engineers in the academy, invariably, for example, Professor Narasimha is an engineer, but he is as much a theorist, fluid dynamicist also. That kind of people. So, name is not important, but I'm saying that interest has to be somehow in the fundamental aspects of things and all. Applied aspects are important, we all know that. But if something very fundamental happens, applications follow. So I can't make any exclusive statements like that, but I would say that its emphasis should remain on sciences. So no point expanding unnecessarily. What we have, we are a reasonable size institute. Our fellowship numerically is also reasonable. We are compact. And I think we should stay that way. On the other side is the main, ultimately, the people who elected fellows are what constitutes the academy. And that should be naturally always. One expects them to be the best available. And the process should be made as simple as possible. But it should be transparent in the sense, transparent means, I don't mean transparent. It should be confidential, but one must make sure that no other influences act. See, the question is, in many other places, a job, for example, or other influences operate. Academy should be insulated from those influences. This is a problem in our country, these influences. I mean, these have no place in academy. Should not have any place in academy. But it should be carefully nurtured. A lapse on that front, these things creep in then. So rigor of academy should be maintained at all costs. But it should stay small only. Membership should not be enhanced to great. Numbers don't constitute quality. They should be reasonably manageable. But see me, one is, of course, to encourage scientific temper, as I say. I mean, the science is important. Whatever else you do, science you must do. No matter, there are people who specialize very early. I don't like those things at all. There is science up to a point should be common to all. A person who has not done science at any stage, in my view, is an incomplete person, no matter what else you do. Because capacity to understand becomes limited. Exceptions, of course, are always there. There are people who, by science, I don't mean he has to have a PhD or something. I mean, I'm not talking about that kind of thing. But science, in terms of what science does, understanding things, analytical skills, mind, thinking, every cause has an effect, for example. I mean, these are scientific tenets. They have to be there. So my feeling, there is a basic science which should be common at a very early stage in our education. And India as a country should see that. Any specific area should be left again to the interest of the students. But whatever he takes up should be encouraged then, supported. Our problem basically is not with science in India, but with what we do with it. The way it's managed, particularly in the atmosphere in which we live. For example, changing from engineering to physics. I told you, impossible. The doors were closed. But then there were some places, indirect ways. You go to chemistry first, and then, indirect way, to NCL, be a maintenance engineer. Things of that kind. So those challenges I don't think are there anymore now, because, and I'm glad they are not there anymore now, because those are negative things. Why should the chairman of the physics department of University of Pune, you tell me, oh, but you are an engineer, how can you do physics? How can you tell me this thing? This kind of barriers should go away. I think they don't exist anymore. At least not in the context of the academy and all. Maybe elsewhere they are still there. I think smaller universities, they are still there, or other places. They should go. It's a very big hurdle to the progress of science, or in the flowering of a budding scientist or researcher, to face this kind of hurdles. One doesn't expect them in modern times. I think they are much less now, as far as I can see. But I faced that. That's the only hurdle. But after that, I had only a success story. I had no problems. And finally now, do I have Any regrets? Well, yes, I do have some. Despite being surrounded by so much physics at RI, I wish I had spent some more time of my life in science trying to understand Einstein's general theory of relativity, GTR. More so, following the recent direct detection of gravitational waves from the distant inspiraling and coalescing black hole binaries. Are gravitational waves really waves of space-time? Distortion traveling in space-time itself? We know the universe is expanding, but if the universe is all there is to it, what is it that it is expanding into? Is it expanding in and of itself? Can I fall off the universe? Or is the universe actually finite but unbounded? Or perhaps not even this? I wonder. I will end by saying, Neti, Neti, Neti.